welcome back to my YouTube channel MS Maths. In this video, I will explain you the concept of series of real number, and this is a part 2, and the previous two parts. Sorry, this is the part 3. In the previous two part, you can get the concept of basics of the series, and in which we have discussed one more thing that is related to this particular topic. It is p-test and some important test for convergency. So in this video, we'll see one more method to identify the convergency of the series, that is what the D'Alembert ratio test, and one more is that Cauchy condensation test. Okay, so from here we'll see. Okay, first we'll see the D'Alembert ratio test. Okay, what is the D'Alembert ratio test? Whenever you have any of the series like this an, okay, summation an, then it may convergence, or let's say it is divergent, but it has no it has no case of oscillating, as the sequence has oscillating, but series does not have any case of oscillating. Okay, so from here that we'll see one more test to identify the sequence as let's say the test is what the D'Alembert ratio test. Okay, so what is the meaning of this D'Alembert ratio test? So in which you have any of the sequence of this form. Okay, if you have any of the if you have any series of this form an and power 1 by n, means nth root of this is what the nth root. Okay, this is also known as nth root test. Nth root. Okay, if it is nth root, then if the limiting value is L, let's say the limit a n power 1 by n is L, and which is what, if your L is less than of 1, then this sequence is convergent. If L is greater than of 1, then this sequence is divergent, and if L is equals to 1, then that test fails. Means if you have any of the sequence an, if you have any of the sequence in which there are some powers, like let's say power n, so if an power n, then you can use this 1 by n or whatever. Okay, in like what case we'll use, that I will explain to you. So we'll take example and why it is happening here. So we'll take example, let's see summation 2 power minus 1. Okay, so summation 2 power minus 1 power n minus n. So what is the meaning of this? So an is nothing but 2 power minus 1 power n minus n. Let's say this is my an. So by root test, so we have what? Root test. So from root test, we will just apply n by n. So it is what? So 2 power minus 1 power n minus n. Okay, so it is nothing but 1 by n. So this is what root test says. Okay, so from here it is 2 power minus 1 power 1 divided by 1, and this is going to be 1. So now from here it is nothing but, if it is n tending to infinity, so now if it is n tending to infinity, then it is what? It's going to be minus 1. So okay, this is going to be 0. So as, let's say, we'll take the limiting case as n tending to infinity. So it is nothing but e to the power, sorry, not 2 to the power of 0 minus 1, and this is nothing but 2 power minus 1, and this is going to be 2, and this is less than of 1. It means it is convergent. Okay, so this is called one of the tests that is known as ratio test. Now the same thing that we can use root test. This is what? Nth root test. This was basically the let's say this is not root test, we can say it as in the modified version by nth root test. One more test is there, that is nothing but root test. So this, with the same example, we can also see. Okay, so from here you can see ratio test. What is the ratio test? Not root test. What ratio test says, that is what nth root test, and now we'll see the ratio test. That is what limit n tending to infinity, that is an plus 1 upon an. Now it is what? 2 power minus 1 power n plus 1. Okay, minus n minus 1. That is what we can say here. Okay, now divide by 2 power minus 1 power n and minus of n. So from here, what can I write? So simple. From here, if I will write like this, so if I will write like this, first one, a 2n plus 1 upon a 2n. So it is nothing but 2 power minus n. Okay, minus 2n plus 1. Okay, divide by 2 power 1 minus 2n. So from here it is 2 power minus n minus 2n minus what? Minus 1. But from here also we can do one thing. Wait, if I will write like this, let's say from here it is 2 power minus 1 power n minus 1. So it is 2 power what? Minus 1 power n, and it is going to be 1 plus 1, and minus of minus 1 power n, and this is going to be plus of n. Now just take it as 2 power minus 1 power n minus of minus 1 power n, then minus of n plus n and minus 1. If you write like this, then this is going to be 0. So 2 power 0 minus, okay, this will get cancelled, okay, and also this will get cancelled, and this is what? 1 by 2 from here. But wait, if it is it 1 by 2? Yes, it is also 1 by 2. So it is less than of 1, and again this is convergent. So this, from the ratio test also you can also find, or you can identify that this is a convergent or not. This is the one of the important test here. Okay, we can take one more series and we can identify that this series is convergent or not using the Cauchy root test, or we can say that ratio test. So I will just recap it. So there are two test, that is what the root test, or let's say nth root test, in which you have any of the series an, and you will just find the limit of this. Okay, we'll just find the limit of this if it is L. Then if L is less than of 1, then you will say it is convergent. If L is greater than of 1, then you will say divergent. If L is equals to 1, then you will say that test fails here. Another route is what? Ratio test. Another test that I have explained in the previous lecture, that is what? The summation an, then you will find the limit of, okay, so you will find the limit of an plus 1 divided by an if it is L. Then if L is less than of L1, L is greater than of 1, L is equals to 1, the same cases will arise here. From here the test will fail. So this is what one of the important thing, and these are the ratio test. Now we'll proceed with the Cauchy condensation test. This is one of the important test. Okay, and this is for a specific kind of series. Now, what kind of series? If you have any, there are two cases. I will first take a specific case and then I will go for general case. So, if you have any of the series like an, and it is what? Positive term series. So, it is positive term series. Then, the sequence is monotonically. Now, it's a sequence. So, from here, so if it is an, or this is particular kind of 2 power n and a 2 power n, it means my n is equals to 2 power n. Or you can say it is nothing but p power n, a power p power n, where p is greater than or equals to 2. Then you will apply this test. Now which test? So from here, it will converges or diverges together if p is greater than of 0 and less than of 0. Now we'll take one example from here. Let's say we have one example like this. Now check for convergence and we'll find the series, and in that case we can use this test, Cauchy condensation test. Okay, so this is what one of the important tests here. Now we'll take example so that we can take example on both the methods. So first, let this is one of the series, that is what n is equals to 1 to infinity, 1 plus 1 by n power 1. Now what is this? Okay, so what is your n? That is nothing but 1 plus 1 by n power n. And what is this? It is simple. It is nothing but L. Means it is not equals to, sorry, it is going to be E. Wait, E, and this is, let's say, L. So what is the value of E? It is 2.75 something. So if it is greater than of 1, okay, now if it is what? It is equals to E, and we are applying L, limit n tending to infinity. So it is by necessary condition, it is not going to be zero, especially if it is not going to be zero, then we can't say anything and it is going to be divergent. Now, if you have any of the example like this, summation n is equals to 1 to infinity 1 minus 1 upon n power n, and you have just applied this. Wait. Yes, you have applied this n tending to infinity, then 1 by n, wait, n square. Yeah, it is n square. Now it is n square. Then you can apply what? An power 1 by n. So it is what? 1 minus 1 by n. So it is n square into 1 by n. Now it is what? E to the power minus 1. And it is 1 upon e, which is less than of 1. It means this an is going to be convergent from here. Okay, this is what one of the like method to find the convergency or the divergency of sequence. Now see one more example from here. If it is 1 plus x upon 1 factorial, 1 plus x square upon 2 factorial, like this, it means summation of x power n upon n factorial. So my an is going to be xn upon n factorial. So what can I do? I will apply the ratio test. I can apply simply the ratio test. Okay, from here I can't apply. If I will apply root test, then what will happen? So it will like this, 1 by n into n, this will 1, but 1 n factorial power n. Now if it will be n factorial by like power n, then it will like more difficult for me. Okay, so I can apply that thing, but yes, okay, I can apply that thing. Okay, but for that you should know that result. So the limit of n factorial power n is going to be 0. You should know sorry, this should be infinity as n tend into infinity. You should know about this. So now I can apply x power n. This is n factorial, and if it is 1 by n, and if I will apply limit n tend into infinity, then it is going to be x upon n factorial power 1 by n. So as n tending to infinity, this will be x upon infinity, then this will go 0. It is less than of 0, it means this is convergent. Sorry. So from here I can say my summation an is convergent series. So this is what one of the case here. So using the comparison test and root test, we can find the solution, or we can find the, we can say that we can check the convergency of this particular method. So there are two important methods which is known which is basically for like series is, that is what the DL number ratio test and Cauchy condensation test. Now come to Cauchy condensation test. So if you have any of the sequence like this, so 2 power n, a 2 power n, then you can use this test, and it means that it will converges or diverges together if p is greater than of, if p is greater than of 2. Okay. So now here we'll convert this test. Okay, we'll see this test. So I should take one example of this. Yes, I should take one example of this. So if you have any of the sequence like this, so now I will explain you again what the Cauchy condensation test. What is actually the Cauchy condensation test? If you have any of the sequence like this, let's say summation n is equals to 0 to infinity, then 2 power n a 2 power n. Okay, this series considered as convergence. This is nothing but as a harmonic series. Okay, this is like considered as a harmonic series, and now we'll take one example of this so that it will get clear. If you have, let's say, summation log power p, if you have any of the we can use the Cauchy condensation test. If you, okay, one example that I have, I can choose, let's say summation, okay, if it is in log form, let's say 1 upon n. Okay, if it is like wait, yes, I can take one example, that is summation I is equals to, sorry, n is equals to 1 to infinity. Okay, if it is n is equals to 1 to infinity, and it is nothing but log of n by n. Yes. So if it is like this, then use this. It means replace n with 2 power n. So, or multiply with 2 power n. So your series will get log of 2 power n divided by 2 power n into 2 power n. So from here it is what? It will get cancelled, and this is nothing but your summation log power 2n. Yes, now it is what? Summation n, and it is log of 2. This is constant. To take it outside, then it is log 2, and it is what? Summation of n, and it is nothing but what? Constant. And you know the constant series is what? Or simple. Okay, if it is not constant, sorry, it is not constant, then you can write it as 1 upon 1 power minus 1. And here p is less than of 1, it means that it is divergent. If it is divergent, then this is also divergent. One more example that we can take. Let's say summation 1 upon n log n power 2. What about this? Will get converge or not? So just if what is your an, that is what? N into log of n power 2. Now multiply this with, now multiply this. Okay, just replace n with the 2 power n and multiply this an, like 2 power n into 1 upon, sorry, 2 power n into a 2 power n. Now what will happen? Just see this. So summation, this will get 2 power n, and this is what? Log of 2 power n whole square into 2 power n. Now from here this will get cancelled, and this is nothing but 1 upon, this is log of, okay, n log of 2 whole square. So from here I can simply write this is nothing but log 2, because it is a constant, log 2 whole square, and it is what? 1 upon n square. Now it is summation of 1 upon n square from p test. Okay, so from p test, here it is what? 2, which is greater than of this. It means this is convergent. If it is convergent, then we can say this original sequence will also get convergence. So this is basically the concept of Cauchy condensation test and DLM but ratio test. Thanks for watching my video. Keep watching MS Maths. We'll see you in the next video. Thank you. Bye bye.